Are we good to go, Anurag?
Yeah, I
Kshitiz?
guess we can start.
Yeah, yeah, sure.
Yeah,
So,
okay. I'm audible and visible, right?
yeah, yeah, Kshitiz, you're audible.
Oh,
So, hello everyone. Good evening, and I welcome you all to our session 2 of DSA Diaries, that is loops, arrays, string, and number. So, for this session, today we have with us Kshitiz Verma. Just a quick intro about Kshitiz. He is upcoming project intern at Samsung Prism. He's problem setter at iMocha, and he's incoming software developer at Ion Group. More about the Code Chef profile of Kshitiz. He is winner of Code Chef Creator Contest, and I guess he's best fit for today's session. Uh, I hope you enjoy all and learn a lot. So yeah, over to you, Kshitiz.
yeah. I'll just share my screen. Yeah, I hope it will be visible, right? Yep, it's
Yes.
visible. Yeah, yeah, fine. So yeah, so today we'll be looking at the topic is like loops, arrays, strings, and the number theory. And okay, before we begin, so to make the like this session is quite interactive, I'll just ask you a very informal question right now, okay? And you can uh, like respond to that on text on Google Meet, right? So say if I'll say you that say you are a coder without saying the word coder, you get it right? Without like including the word coder, how would you say that? I'll just look at your responses. One second. Yeah. So, okay, using asking numbers. Okay, fine. And anything interesting you think? Yeah, copy paste is what I do, right? From yeah, geeks for geeks say for CP or Stack Overflow for development, right? And okay, using algo, fine. Anything else? Anyone wants to say? Like it could be like I put semicolon after every line. Yeah, hello world. Yeah, that's a nice way to introduce also, right? Cool. So yeah, any point of time if you like having doubt, you can text it. So if you'll text in the meet, I'll have a look at the end, right? Because I will be at the presentation, right? So, but still, if you want to ask in between, you can use your mic, right? Fine. So let's move on. Okay, moving on to why we are here. So as I said, we'll have a loops basic introduction, how it works. Then we'll have arrays and basic like most of the functions which are very much useful in your CP and as well as in any question, right? The basic ones which are mostly used, basic function. Similarly for the strings, we'll have all the functions and what's the difference between string and the character array and all such things. And after that, we'll have a question over all these three topics combined, say loops, arrays, and strings combined. And then at last, we'll be looking at the number theory. And today we'll be covering few algorithms. As you know that there are various algorithms that, inside the topic number theory. But today we'll be covering Euclids Algorithm, C of LHS, and Williams Algorithm. And I'll be sharing some resources and other algorithms which you can learn after the session. And I'll also be giving you the practice problems which you can have a look after the session. Fine. So moving on to our first topic, which is say loops. So what basically loop is a like sequence of instructions that is repeated until a certain condition is reached, right? As the term itself loop suggests us. So what happens is yeah, what sorry, okay, I'll move on. Yeah. So at start, like we'll have a start and we'll have a condition. If it's true, then it will execute the following statements, whichever would be there inside it. And if it's not true, it will come out of the loop. So that's the basic like idea of the loops. Moving on to the types of loop, we have for loop, while loop, and the third category which we have is do while loop. So since most of you, I think, would be basics since you're starting with this topic. So I'll be presenting out all the layouts of the code in C++ language, but similarly, it can be done in any other programming language which you prefer. So for loop is just simply a for and then initializing it with say int of I, or it could be anything, any other type of data, right? And then say from this is the starting initial condition, and this 10 is the like ending condition, like till 10 we want to have like execute the following statements. And what would be the step with which it would be incrementing is I plus plus, that is one by one, one two three, then up till 10. So it will print out what this program will do. It will print out hello world 10 times, right? Similarly, if you want to do that using a while loop, we'll have say like here we have initialized it with int I equals 1, and then till I is less than 11, or we can also do it like till I is less than equal to 10. Both are same, right? And similarly, this piece of code would also print out 10 lines of hello world code. So these both are basically like similar, and I don't think like you guys might have any other doubt in this topic. And if you have, you can ask me, right? Then moving on to do while loop. So what's the difference between do while and while loop is, in do while, it firstly executes the given statement, right? Then it checks the condition. So even if the condition is false, it will execute one time at least. Say if I here we have initialized it as int I equals 1, right? And if my while condition is I is less than 0, right? So even though the condition is false, but this statement would be printed once, and then in the next iteration, this like piece like this loop will not work because of this while condition. So what I mean to say is, one time execution is confirmed, and rest it depends upon the condition which we are fixing here, right? So this was all about loops. It's a pretty basic and short topic. Now moving on to the more important parts, say arrays. So arrays is a very basic data structure which you'll encounter whenever you'll be like entering or you'll start studying DSA, right? So what basically array is the collection of similar data types. So yeah, it doesn't have like on zeroth index it will have an int type of data, and on one index on first index it will be having char type of data. So that's not possible, right? It will be storing a similar type of data in a continuous memory location. So what array does is, whenever we initialize array, it takes the like memory size from these in the main memory. It takes the continuous locations in that memory. So say if it's an int type, if the address of the first one is say 1, then the address of the second one will be 5, since it takes a space of 4, right? So in that way, it stores the data in a continuous manner. So, and one thing to remember here is the indexing of array starts from 0, not 1. So that you guys might know. Then, yeah. So it can be of any primitive data type, say int, float, double, char, or any primitive data types, right? And yeah, moving on to some basic array functions, and you'll be using quite a lot of these functions. Okay. Everywhere in your like any basic programs which you'll be writing in your say basic DSA questions or CP questions, if you're using array. So the very first one is like let's start with the basic, how to like initialize array with a specific size. So say it's of int data type, okay, and so that's the data type of the array. So it will be storing all the integers in it only, and it is the name of the array, and this is the size. 10 is the size. Okay, and if you want to like initialize the elements also without specifying the size, so that's the second way. Int array and the square brackets and whatever elements you want to initialize it with, you just mention it out inside the curly braces. Okay, and then suppose, say in the first array, this one, we know that the size of the array was 10, but in the second like this array one, we don't know the what is the size of the array. So in such cases, if you want to find the size of the array, so how we can do that? So the basic logic is, we can divide the size of the array with the size of the first element. So why we are doing this is, size of the array would include complete size of these all four elements, and dividing it by the size of a single element, right? It will give us the total number of elements. So it would be like the size of the four arrays, four elements divided by the size of one element. So it will just definitely give us the size of the array, which would be four. Now the second most important thing inside the array is this mem set. So what it does is, suppose in DP problems further, let's just say in DP problems, sometimes we need to initialize the whole array with, say, false condition or zero condition or one, or let's not say just the DP questions, in any kind of situation, right? You can face any kind of situation where we are just initializing the array, and it's a very long array, and you need to like initialize all the elements of that array with any particular value. Fine. So you can use the function of memset. I'll be like showing you the practical also by running the codes. I'll just explaining you what the functions are as of now. So how the memset like syntax is: memset, and then the name of the array, and the value which you want to initialize it with, and the size. Like, what's the size, like till what elements you want to initialize the array with. So we are just mentioning the whole array, right? So if you want to initialize the whole array with zero value. Now, the like suppose if you have an array and you need to find out the maximum element of that array, these are just simple functions for which you don't need to write for loops. Suppose if you want to do the same function of like initializing the complete array with zero, so how you would have done with a for loop is, you would have write for, then till I equals this to the size of the array I plus plus, and then initialize all those values with zero. So that's a we can do that in that way also, but that's a pretty long way, right? So these are just one line functions which you can use in your like day-to-day programs, whichever you will be writing. Now to find out the max element, the syntax is like, since it's a pointer based, you just don't need to get in depth into it. So but the function is pointer max element, then name of like the initial address of the array. So if you don't know, the array name itself stores the initial address of the array. Okay, I'll repeat it again. The array name itself, this array one itself, stores the address of the first element of the array. So if you guys know the pointer concept, if you will point the okay, there was some disturbance. Okay, I'll continue. So if you have, say, pointer, where if you know the if you guys know the concept of pointer, if you don't know, we'll be discussing it later. But if you guys know, if you will point array one, you will be getting the first element of the array. So that's why array one is the initial address. Okay, okay. We'll be covering vectors. Just a second. I'll be mentioning that. Fine. We'll just touch the vector because it's not the like discussed topic for today. We'll just that I'll just leave it to you guys. I'll just introduce you, and it's a pretty simple. If I'll just introduce you, and you can look into it. Right? It's very similar to arrays. Okay, so I was at here like max element, and this is the ending like ending address of the array. Since I mentioned that array is a continuous uh, block of memory, so if I'll uh, add the size in the array's first address, I'll get the end address, right? So that's basically denoting from here to here. I need to find the max element. So if you in the similar way, we can have min element instead of max. If I write min and underscore element and the same syntax, then it will give me the minimum element of the whole array. Okay, so I hope that's clear. And the last one is sum. Again, this thing can also be done using a for loop, right? You can initialize, say, from I equals 0 to the end of the array, and you'll just plus it. Sum plus equals, and all the elements you'll just add to the that sum variable, right? But if you want to do that in a single line, it saves a lot of time, right? And so you can use accumulate function, accumulate array one and the ending address. And what this zero is, okay, zero is my starting sum. If I'll write zero, then it will give me like zero plus all the elements. If I'll write one, then it will give me one plus all the elements. So this is my initial sum, and whatever I'll be getting inside this sum is the my final sum of the whole array. Fine. So let us just quickly. Uh, okay, I'll mention vectors also. Then I'll run the code. Yeah. So what basically vectors are? So here you can see I'm like statically means like by myself I'm like giving the size also of the array, that these many elements should be there inside my array. But what vectors are the dynamic arrays. Dynamic terms means that you don't need to pre-specify like these many elements for these many elements I need the memory, right? If I'll say here array 10, then if I want to include the 11th element inside this array, I cannot do that because I have only the space for 10 elements, and I cannot store the 11th element now inside this array. So but in case of vector, we don't need to specify any size, okay, and we just can go on adding the elements inside it. So it's kind of a basic dynamic arrays. And another difference is in arrays we can only have a primitive data type. What are primitive data types? Int, float, and the char. These kind of data types are primitive. But in vectors we can store like non-primitive data types. Say what we can say pairs. If you go into STL is a standard template library. So it's a part of vector is also a part of STL and C++. So you can store non-primitive data types too inside the vector. I'll run the code quickly to just show you that uh, right. Uh, so like this is the same piece of code which we discussed right now, and we'll just see the output. Or maybe I should run my offline compiler. Okay.
Kshitiz, I guess you run it on your local compiler.
Yeah. Yes. Okay. Yeah. Okay. It's working fine. Otherwise, I would have just moved on. Okay. So if next time I yes. Before that, like this was the initialization, and to see like it's giving me max element equals 40 in my array, which array we searched it for, array 1. So here is the array 1 and my maximum element is 40. Similarly, I said you earlier, right? If you want to find out the min element, so we can use min, right? Min and then element. Don't look at here now. Okay, I'll change that too and just run it. So this time it should give me 10, right? Yeah. So you can see it's giving me 10. So these are like the pretty basic functions which we have discussed right now. Then, uh, okay. So now a question for you guys. I've already hinted out this right now while explaining arrays. Could you tell me like what would be the output of this program? I'll give you 2 minutes. Can you think of like what would be output of this program? Okay, just a second. What I'll do is, okay, now it's very small. Still, okay. So I, I, I hope that you guys might be able to see this code. Okay,
I guess no, it's not visible. Like it's very
not
small.
okay. Okay, okay. I'll go
Yeah.
to full screen and then afterwards
I will
I will
recite the
look at
answer.
the
Like if
comments.
someone writes in chat books, I will recite answer for you.
Oh, okay, okay, fine.
Yep. So
So any
Shreya
like
has written 5, 5, and 7.
five, five, and seven. So Shreya, like the very first element is wrong. Like this could be, if you look at it, a of 0, which is not 5, right? I guess like you have missed out this. Okay. So let's check your answer. Like I'm guessing that you have missed out that. I'll checking from the second one. So a plus 2, she's saying 5. Okay, it's fine, 5. Then it's also 5, and that's yeah. You're correct. I think that you might have missed a of 0. So yeah. So the answer is 2557. I'll be explaining you now why. So like 1 second. Yeah. So the A of 0 is pretty clear, right?
Excuse me,
The
sir.
first element. Yeah, sorry.
Sorry to interrupt you, sir. I got this link from my friend. Sir, can you tell that why we have this meet for? What are we doing here?
Okay, so this is a DSA Diaries event of CodeChef
Yes,
CDC
sir.
chapter, and this is a DSA Diaries event of CodeChef CDC chapter and UMIT chapter. So today we are teaching loops, arrays, strings, and number theory. So like if you are interested in learning DSA, you can stay here. Otherwise, you can leave the meeting.
Okay.
Yeah,
Is it of any particular college?
like we are from CDC Landra and UMIT Mumbai. So if you are interested in learning DSA, then you can stay here. Otherwise, it's your choice.
Which topic we are doing here in DSA?
Loops, arrays, and number theory.
Okay, fine.
Yeah.
Oh, okay. So so yeah, first element is like A of 0, that's 2. And then I already mentioned like right now. So A, which is the array name, stores the first address. Stores the first address. I pointed out in my previous explanation. So A is pointing towards this first address. Sorry, address of the first element. Then I am adding 2. That means I am jumping like to 1 and then 2. I am at this address of 5, like the element 5 where it is stored, and to like it's a pointer concept. So if you like point towards the address, it will give you the element. So I'm pointing to this address, so it will give me the element 5. Similarly, a plus 2 and 2 plus a are same, so it gives me again 5. And also one more thing, in arrays concept, 4 of this a and a of 4 are both same. So that's one new thing for you guys. Okay.
Here we are using bitwise operator.
No, no, it's not a bitwise. Like it's that
Left shift and right
C,
shift. Those
yeah,
operators.
no, no, it's a C plus plus syntax, right? C out, then we mention this. It's a
Okay.
syntax. Okay, okay, yeah, right. So not a bitwise. Okay. Uh, yeah. So 4 of A and A of 4 are both the same thing. Good. Then now moving on to the strings, and yeah. So like arrays and for loops, and these are like pretty simple topics, and there's not much in depth for in terms of programming. Like theoretically, there are some few more concepts, like these small concepts, uh, which once you start exploring, you'll easily get to know them. So now moving on to the strings concept. So what basically string is, like string stores the characters as a C, right? So in character array, say we have a character array, but it stores single element, right? If we initialize the array of character data type, it will be storing single characters in one location. But string is like collectively, like those sequence. There's a sequence of bytes, right? So it forms a string. All the characters collectively they form the string. Cool. And one more like basic difference is like in the character array, it is terminated by the null character. You guys might not see, like while you will be initializing, say you will say that okay, I'm initializing character array by name array, and I'm in that I have elements A and B, and I'm not able to see any null character. But by the like what's happening behind the screen, what the compiler does is when you're initializing the array character array, it ends the array by default with a null character. Now, what the null character is, if I can type out here, okay, you guys might know, might some of you might know, some of you might not know. So, what they are like null character is backslash zero. Okay? So, like that's the null character by which it's ended. Okay, and in some languages it's also same like null or it's nullptr. Okay, it depends on the language. Okay, now moving on to some important operations and
Excuse me, sir.
functions of the string. Yeah, sorry. Oh, oh, fine. So say like this is how similarly
Sir,
of
can you repeat
integer.
last question again?
Okay, okay, I'll repeat. Which point you want to like this null
Sir,
null
last
character one?
question.
Last question.
Yes,
This one. Okay.
yes.
So this one is like a of zero. That means we are pointing like we are getting the zeroth index element, right? A of zero. So that's two. Then a of like if you know the pointers concept, so that was like that's why I included this one. It's a tricky part. So as I mentioned, what you need to keep in mind is the array name. That array name, stores the initial address of the array. So you just keep it in mind that it's a concept, right? That the array name, that the array, right? It stores the address of the initial element. So that would be address of two. Okay, as I mentioned, array is a continuous block of like when we initialize, it gets a continuous block of memory, right? So A stores the address of two. Now we are adding plus two. So we are going to the address of since it's a continuous memory, right? So there is nothing in between two and four. So the next one is four. That is plus one, and plus two is my like fifth like five wala element. That is my second index. So I'm at pointing at the address of my second index. So the element at my second index address is five. That's why I'm getting five here. Similarly, a plus 2 and 2 plus a are same. So again, I am pointing towards the same address. So again, I'm getting 5. Now you can this fourth part you can take it as a syntax. So as we know that the syntax to get the element of array is a and that the index. Similarly, another fashion of writing it is 4 of A. 4 means the index value, and A is my array name. So these are like two different types of getting the elements of the array. Right? So I hope it would be clear.
Okay, thank you.
So, so now moving on to like some important operations and functions of string. Like these are like if you'll be solving basic DSA problems in for interviews also, right? And if you are getting the topic of string, at most you'll be using these kind of functions, or maybe function. I'm talking about functions, okay? So you might use 3 4 more, but these are kind of enough. And further, you'll be like there might be many more, and I also use many more, but these are like the basic ones. And once you'll be start like you'll be practicing questions, right? Then you'll be searching out on Google, right? How to do that and how to get this in strings, right? Then you'll be exploring more things about string. So it all starts with basic, but when you try to explore it, you'll get to know more. So I'll be telling you the basic ones. Now to initialize the string, we write the string, it's a string type and the whatever name you want to give. So string str, and another I am declaring str2. So these are just simple initialization of the by the data type string. Now string str3. Again I am now initializing it with a string. Okay. So equals hey. So one thing to remember is string are initialized with double quotes, not with a single quote. With single quotes, characters are initialized. Okay, we store characters with the single quotes, and with double quotes we have string. So that's one thing to keep in mind. Now, get line. What's the difference between get line and cin? If you guys know C++, if you might have used C++, then cin is used to take the input, right, from the user. So if I'll do cin str2 in str2 and getline str, what the difference is? It's better to show you, I think, with program. Where was I? Okay, so I'm running it, so you'll see. One second. So first of all, you can see I'm taking input from a user. One way of taking input is a get line. So I'll mention you the difference later. I'm just right now giving the input. Say hello there, right? And enter. Now this C in str2 is going on right. So whatever I'll be in giving the value, it will be stored in str2. So suppose here again I'll give hello there, how are you? And then I'll press enter. So keep everything like I'll be explaining like this is all because of the further program. Ignore it. The highlighted part, ignore the highlighted part. 1 second, right? Or I should have commented it. No problem. So look at this part. Okay, I'll highlight this. So this hello there was my string, and hello there how are you was my str2. Now when I am here, you can see cout, right? I'm doing cout str and str, then cout str2 is my str2. Now with str I'm getting hello there. I'm getting the whole line because of get line, because I was taking the whole line. That is why I'm getting the whole line as the output in my string2. Whereas while I was using cin, it just took the first part, that is hello. Why this happened is whenever you will be using cin, so it will break at the space. Okay, whether it's a space or whether it's a enter. So right, whether whenever there is a space or an enter, like it will take up to that only. That's why str2 was storing only till hello. So these two, like this, both of these things you might be using in your day-to-day program. Sometimes you need to take the, like the before space, right? The first continuous string without any spaces or something. Sometimes you need to take the whole line. So at that time you will be using this getLine uh, function or type, like that, right? So what getLine syntax is, getLine cin, and then you mention in what you want to store. I wanted to store in str. That's why it's storing in str, and c in str2. So that's the basic thing. Okay. So that was the difference between getLine and cin. Now moving on to str3. Now what I am doing here is, you can look out here, plus equals. Okay. So what plus equals means is, I'll further simple out it for you. Where was it? Okay. So this line is same as, okay, so str3 equals str3 plus how are you. What it means is, I am concatenating it. What concatenating means is, I am adding this part of this string with my already existing str3. So whatever in str3 would be stored, I am adding this string after it. Okay. So as you guys can see here also in the output, this line, my str3 becomes, earlier it was, you can see here on the seventh line, I'm highlighting here also. Earlier it was string str3 was hey. After adding how are you, it became hey how are you. Okay. Now as you guys might also see, uh, here only hey how are you was there without question mark. But if you want to add a single element, right, you can, instead of using concatenation, you can also use pushback. That's another method. The name of the string, then dot pushback, and whatever, uh, it's for a single element. Okay, not for this whole string. If you want to add whole string, you need to use this concatenation. So that's why my like the str3 became hey how are you with a question mark. Now if I do str3 dot popback, you can see I'm highlighting it in line 20. So popback means it will delete the last single element from the end of my string. So it deleted my question mark. So now my string 3 became, I'm highlighting in the output here, without question mark, hey how are you. Now one more function is, whenever you'll be like solving programs at some given point of time, there might be a case that you want to uh, make the string into int data type, or make the make the int data type to string data type. You want to do these type of conversions. So say right now I'm having str, in my str4 I'm storing 1234. Okay, it's a string, not a number. Okay. uh, can you use that in C? Which thing? This HTOI, all these things? No. These are for C++, and all of these come into HTL libraries. Okay. So, and to include all the HTL libraries, uh, till now you guys might have been using hash include iOS stream, right? Hash include and iOS stream. But to include all the libraries at one go, what you can use is this hash includes bits slash stdc plus plus dot h. So it's a library which includes all the HTML libraries and basic ones, right? So it's all in one pack. So you can just include this and go on with your program without worrying that I need to include this library also, I need to include this library also. So it's a pretty easy, fine. So yeah, I was here 1234 is a string, and I need to make that as a integer. Why? Because I might have to perform some integer operation in it. Say I need to multiply it with 2, like I'm doing here. So what the syntax is, HTOI. What it stands for is string to input. So string to input str4, and then I'm multiplying it with 2. So what my number would now become is multiplied by 2. So that would be 246A. That's why I'm getting the output. Num is 246A. Now, uh, okay. Now we can convert this string, sorry, convert this number. You can see here, right? Num to string data type. So how we can do that is using the syntax to string, to underscore string, and the integer, right, which you want to convert into string. So it becomes to underscore string, then num. So, and if I need to access any particular element of a string, I can use the index. Okay. So what's the str4 of 2? My str4 was 2468. So what's my second element? It starts with 0 indexing, right? 0, 1, 2. So my second index element is 6. That's why I got 6. Now suppose at any given point of time, you want to convert the whole string in upper cases. So it's a simple syntax, transform and the beginning address, say str3 begin, it points out to the beginning address, and str3.end points out the ending address. Again, it's a kind of syntax. You need to mention the starting index and then two upper for converting the whole string to upper cases, and two lower. Similarly, the whole thing, yeah. So the whole thing remains same. Just two lower comes if you want to convert the whole string to lower cases. So you can see here, hey, how are you? Became into whole caps lock, like whole upper cases, and hey, how are you? In the next line became to lower cases. Now, if you want to find out the length of the string, the syntax is str3, whatever the string name is, dot length. So you can see the length is 15. And to find out the substring, what substring is, any part of the string. Say my string was, hey, how are you? And I need to get the first 7 elements. So you can see H is 1, 2, 3, 4, 5, 6, 7. So till hey, how? There are 7 characters. So that's why if I need to get from 0 index to 7 index, like till 7 element, not index, 7 element. So the syntax is str, whatever the name is, and the substring sub str. So that's why I'm guessing this, getting the substring at a how. Okay. So I'll be sharing you this doc and everything. If you want to keep the syntaxes in mind, or you can just Google it out. You'll simply get these all those syntaxes, right? Okay. So I guess we should look this question at the end if we have some time, or
एक लाख
right?
फिर से यार बोले
Sorry. Okay. Uh, good. So we'll move on to number theory, and at last we'll be picking out the questions, right? Good. So the very first algorithm which we'll be looking. So is there any doubt as of now? So I can in these three topics, so that I can clear. Okay.
No, sir.
Okay. In comments, I'll read out last few comments. Is deadline same as scanner? Uh, yeah, it's same as of like C in. Then deadline takes the whole line also with the workspace, right? Tool and printer scanner can be used in C++, but they are not. Yeah, you can use that, but they are not recommended. Fine. In fact, I'll just mention out one thing to you. Uh, if you look out to many competitive programmers, right, to their codes, so you might find out like in the top ranking, right, after the end of the contest, when you look out to the solution of top ranker solution, you might find out that they are using C++, but they are using printf and scanf statements. So why they are using is, it's not kind of recommended, but what the reason behind is, printf and scanf are faster than C in and C out. You can look out over net also. So printf and scanf is more faster than C in and C out processing. So that's why in C++ you can also use printf and scanf. It based on your like need. then there's a difference in quite milliseconds. But say if you are working in some development and there are millions of users using it, so that quite millisecond also makes a huge impact. So you might not see it in CP, but I'm mentioning just out the reason. Then why we have used scope resolution operator in transform function? Okay, so it's like, I mean, as I mentioned, it's like whole part of the syntax. So yeah, there's nothing more in it to explain, I guess. Okay, CPUSA development we look at the end. Let's move on to the concerned topics of today. So I'll quickly like wrap up these few theorems which we have decided for today. Euclid's algorithm. So what is the work of Euclid algorithm and why we are studying number theory is these small theorems, or we should not say theorems, like these are basically theorems, but in terms of computer science they becomes algorithm when we write code for it, right? So these small logics we can consider them as logic, can be used in our, say, you'll find out these in a long question. Suppose you are participating in any XYZ online competition, okay, and in online rounds, say code chef or code courses, there you might not find the exact question on based on these, like, yeah, you need to find out the prime numbers. No, I'm not saying that. I'm saying that it would be a part of the whole question. Like in some part, you need to get the prime number, then you need to process it for some other logic. So it goes on, right? You combine all different logic. So it might be a important part of the question. Uh, I heard some notification. That's why. Uh, yeah. So as I was saying, so this would be come handy. Like think of it as tools. You have these many tools with you, which you can use in any XYZ program, right? These are your weapons to like solve any question, or these are your tools. So understand in that way, in that sense. So what Euclid's algorithm is? Euclid's algorithm is basically used to find out the GCD. As you guys might have studied in earlier classes in school also, what GCD is, greatest common divisor. As the name suggests itself, you have two numbers and you need to find out the greatest common divisor. Fine. Uh, Two things I'll mention out here. Yeah, HCF basically. Fine. So as I'm mentioning, GCD. So what GCD is? Let's start with brute force approach. Okay. Let's start with brute force. Okay. So suppose you need to find out the GCD of 10 and 20. Okay. Ignore my handwriting because on the whiteboard. Okay. So you need to find out the GCD of 10 and 20. That is greatest common divisor. So as we know that we need to just check out till 10. Whatever the minimum number is, we need to check out till that. Why? Because at most to at most that would be the maximum common divisor, right? Greatest common divisor. So say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you're checking till 10. So what you need to check is whether it's a brute force approach, right? So you will check till 10 completely one by one, and you need to check that whether it's dividing both the numbers or not. So yeah, one would divide it. So we say that till now one is the common divisor, sorry, greatest common divisor. Then two, yes, two is the two also divides them. Three, it doesn't divide them. Four, it doesn't divide both of them. Not all. Yeah, five divides them. Six, no. Seven, no. Eight, no. Nine, no. 10, yes. So suppose you have a variable by name GCD answer, you'll be keep on updating it. When you'll find out one, you'll initial put it equal to 1. Afterwards, you'll put it equal to 2. Then you'll put it equal to 5. Then you'll put it equal to 10. And at last, you'll be having your answer as 10. So that's basically GCD, which is the greatest common divisor. So it's a brute force method, right? But suppose you have a very long range, so it might become a problem for you in terms of time complexity in some problems. So in that cases, what we use is Euclid's algorithm. So let's see what basically Euclid's algorithm states. So before starting, there's two things that Euclid's algorithm says is that it states that GCD of A comma B is equal to GCD of B comma A mod B. This is the first thing, and the second thing is GCD of A comma 0 is equal to A. These are the two things which you need to keep in mind with the GCD theorem says. So this could be a recursive case. This could be a recursive case, and this could be a base case. What is recursive case? Recursive cases, because you can see, right, GCD is again calling GCD, so it goes on again and again. And if we are writing the recursive function, and this is our base case when it ends, because GCD of A comma 0, whenever we encounter 0, its greatest common divisor is A itself, right? Okay. So yeah, using these two concepts, we will be let's dry run a program. Say we need to find GCD of 10 comma 16, so that you get to know like how it works. So GCD of 10 comma 16 is, I'll keep the functions here. So yeah, what it states is B, so it would be GCD of B is my 16 comma A mod B. A is 10, 10 mod 16 is 10, right? So what it does is, for in the very first case, it puts the greater element at A position and smaller element at B position. If initially it was this case, then it would not have been any problem. Now moving on, again we'll do the same thing. So it will be GCD of B. B is my 10, comma A mod B. A is my 16. 16 mod 10 is 6, right? Then again it would be GCD of B. What my B is 6, and it would be 10 mod 6. 10 mod 6 is 4. Then again moving on, B, I'll put out here B. B is my 4. Then A mod B, that is 6 mod 4, which is 2. Then it becomes GCD of B. B is 2, comma 4 mod 2. 4 mod 2 is 0, and this gives out me 2. So 2 is my answer. So in this way, GCD works out. And to look out at the program, the same thing which I said right now. Suppose we have a GCD function by name GCD, int GCD, and there it's given two numbers, int A, int B, and this is my base case. If A equals 0, okay, if any of these one is 0, say if A equals 0 or B equals 0, say because if we are writing in terms of A, so we'll be returning out B. So if A equals 0, return B. Otherwise, return GCD of B mod A comma A, which we looked out right now, or we can like reverse it too. So to show you a dry run of the program, right? So this is my GCD. and this is my main function in which I'm passing a equals 10 and b equals 16. Then I'm finding out the GCD. So it should give me 2, right? And you can see here GCD is 2. I'll be giving out the practice questions at the last, which you guys can try out later. So if you guys have any doubt in this as of now, you can point out here itself so that I can clear it out. Okay, voice is coming low. I'll increase it.
I guess voice is absolutely fine.
Okay, it's fine. No problem. Okay, moving on. Let's quickly. Wilson's is a very short one. We'll have a look at first of all sieve of arithmesis. So before moving on to sieve of arithmesis algorithm, I'll tell you like what basically it is. Why we need to use this algorithm. Okay, we will go on to whiteboard once again. Yeah. So now this prime sieve method, or we can call it as prime sieve method, is used to find out whether the given suppose in any question you need to find out whether that given number is a prime or not. So the very basic method which we can do is, first of all, let's discuss right, brute force approach, right? So in brute force approach, say any number n is given to you. What you will do is, for say int I equals 2, because to check prime you will be starting from 2, I less than n, okay, because any what's a prime number which is divisible by 1 and the number itself. So we'll be, yeah, and then we'll be checking out, okay, inside this condition we'll be checking out like throughout from 2 to less than n, say n minus 1. We'll be checking out whether my this given number n mod I is equal 0. If it's equal 0, that means it is divisible by that I. That means it is not prime, right? And if it doesn't happen throughout the loop, that means the number is prime. So that's the basic like brute. Will look into the code later, like the same thing which I said. We'll write it out in code. So that's the brute force method, checking from like till n minus 1, from initial to the end. So that's the brute force method, right? And its complexity would be O of n. Okay, so you will see that we'll be decreasing the complexity now. Now moving on, like mm, uh, further optimization. Okay, to further optimize it, what I say is, instead of running the loop from I equals 2 to less than n, what we can do is we can initialize the loop from I equals 2 to I less than root of n, I plus plus, and then the condition. So it's okay. Why we are saying root of n? Okay. So why I'm saying that is, let's have a like example to explain it out clearly to you guys. Suppose we have 20. So if you need to check that whether 20 is prime or not, I'll start from I equals 2, and it will be divisible by 2 itself. And thus we don't need to check for 10. Okay. Okay. Like it's basically like 2 times 10 is equals to 20, right? It's based on the like factors method. If we have checked for 2 and it's divisible by 2, then we don't need to check for 10, because any number which is divisible by any number, it will have another pair, right? Two numbers when multiplied will give that particular number. So we just need to check out till root of that. And why only root of that? Not why not till n by 2? Why? Because n into n gives you sorry, root n into root n gives you n, right? And root n is the maximum which you can get in a factor. Okay. say again we take the example of 25. So at the max to max which you can get as a number is 5 into 5. We cannot get anything six, like we cannot get anything like 6 into something would give me 25. Okay, that's not possible. That's why we'll be checking only till root of n, and this will solve my purpose. Right? Anyone have any doubt in this? Why we are going till only root of n? So I can clear it right now. Okay. So if it's clear, then the complexity we can say here is root of sorry O of root of n. So you can see we have moved on from O of n to root of n. So still we have not get the optimized one. Okay. Now suppose now we'll moving on to prime sieve method. Prime sieve of earth masses. Fine. So when we use prime sieve method, when do we need to use the prime sieve method? Suppose we are asked to find out the prime numbers in a given range. Suppose my n is equal to 20 and I need to find from 2 to 20 how sorry not how which all numbers are prime. Then we use this prime sieve method. So one thing which you can do is you can check for all the numbers one by one. Say I'll go to number 2 and I'll check using the above condition of root of n. Right? That loop I'll run the loop for all the numbers to check whether it's a prime or not. I'll check for 2, then I'll check for 3, then I'll check for 4, 5, 6, and it goes on till 20. So that's you can see right that it's a pretty complex method. It will have a it would like it's not an optimized one. So that's why in this case we use prime sieve method. What prime sieve method is? First of all, we'll create an array for say for the all numbers. Okay, 1, 2, not for 1 because 1 is we don't consider in the prime, right? 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Fine. Yeah. So now what we'll do is our loop would be from for int of I equals to say I would be less than equal to okay less than equal. In the above case also I might have missed out. It would be till I equal less than equal to. Okay. Moving on. Till I less than equal to n and I plus plus. So we'll be checking out and what we'll be doing is I'll cross out all the multiples of 2. So I'll cross out, I'll take another color. I'll cross out 4, 6, 8, 10, 12, 14, 16, 18, 20. Now moving on to the next number, like not cross out. So what we are basically doing is here we'll use the memset function, which I explained during the arrays concept, right? So I'll using memset, I'll I'll make whole array as true. True, 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 true. I'll make whole as true. And when I'm crossing out it means I'll make them as false. False, false, false. False means that they are not prime. So we'll cross out all the multiples of 2 except 2, right? Except 2, we'll cross out all the multiples of 2. Then moving on to 3, we'll cross out all the multiples of 3. So 3 to the 6, 3 to the 9, okay. Then 12 is already crossed out, then 15 cross out, then 18 already crossed out, like this. Moving on to 4, it's crossed out, so we'll not worry about its multiple further. Then 5, it's 5, 10, 15, 20 all crossed out. Then 7, 14 is crossed out. So at last you can look out that we are only left with prime numbers. So if I can point out here, 2, 3, 5, 7, 11, 19. You can see that these are my prime numbers. So at last I have got the prime numbers. So to sum it up, what I was doing is I have made the whole array of numbers as true initially. Then I'll if my that element is true, I'll make its multiple, all the multiples till that n. Okay, I'll make it as false, all the multiples. And at last, whichever true would be left, right? Whichever would be non-crossed out, or whichever are the true ones left, are my prime numbers. So let's look at the code for this logic. First of all, I'm creating a bool array of prime because as I said, I'll be having true or false. Okay. Then using memset, I'm initializing the whole array with true, as I mentioned this function concept in arrays. Then for int I equals to root of n, instead of root of n, the same thing is I square should be less than equal to n, right? I square is less than equal to n, or I should be less than equal to root n. These two things are same, right? So that's why we can write it out there as this. And if prime of I, if my that element is true, that means if I'm checking for 2, and if my 2 element is true, then I'll show it in the code so that it's more clear to you. Okay. So now for int I equals 2, say we are going till I square is less than n. And if my prime of I is 2, then from multiple of 2, right? 2 into I till that till less than n, and j is plus I. What I mean is 2, we'll first go to 2 twos are, right? 2 2, and then we'll go to 2 times 3, then 2 times 4, right? That's why jumping it out with I, and we'll make all those elements as false. So at last, we'll just print out the true ones. If prime of I is same as if prime of I is equal to true. These both things are right. Okay, these are same. So if prime of I, then we are printing out the I. That means we are printing out all the prime numbers. So let's run it out once. Okay, so we can see here as 2, 3, 5, 7, 11, 13, 17, 19. We got all the prime numbers in the range of 2 to 20. So is there any doubt in this? Anything I need to repeat? Oh, no, okay. I guess it would be pretty clear. Okay, I'll ask you a question now. Is there anything you can use to optimize here? Anything you are seeing that you can make a change here and you can make the code more optimized? I'll show you the code. Here it's the and this part itself, only this part which I'm showing you. Is there anything in this loop, in this hole, which I have highlighted, which you can do and optimize this code more further? Anything you guys have in mind? Yeah, someone raised the hand. You can say. Uh, J till n by 2. No, no, no. We need to we need to cross out all the multiples, right? So if we go till n by 2, say in the case of 20 itself, if we go till n by 2, that would be like 10. We'll be going out till 10. So for 2 ka multiple, we won't be crossing out 12, 6, 14, 16, and 18 and 20. So according to your logic, they would remain as prime. So no, that's not the one thing. Okay, I'll mention it since we are short of time here. So what we can do here is, instead of 2 into I, we can start searching from I square. I'll explain you. First of all, let it sink into your mind. What I did is, for int j equals I square से लेके we are going till j less than n. Why I square? Okay, I'll mention. Since according to this concept, earlier also, right? Yeah,
Kshitiz, you can continue. They are asking
yeah,
about the poll question. You can continue your
okay,
topic.
okay. So yeah, so prime, yeah. So j, we are going from I square till j less than equal to n. Why I square here? Because as I mentioned earlier also, right? Uh, we need to check, like we need to check from, how should I explain you? Uh, say, as we know that if we are searching for any number n, so we need to just search till the root of that number, right? Because as I mentioned earlier in the previous example here, yeah. So we need to just check out till root of n, or we can say till I square is less than equal to n. Why? Why? Because before that, say in the let's look at the example itself so that you get a clear idea. Mm, Suppose here I'm saying for I square, right? So I need for 2, I need to check from 4. For 3, I need to check from 9. You can see by the observation. When we cross out the numbers for 2, we crossed out 4, 6, 8, 10, 12, 14, and so on. Now, while checking for 3, we don't need to check for 6 because it's already crossed out by 2. And this would happen for, it's a observation based thinking. So this will happen throughout the array. So that's why for 3, we can start with 9. Not, we don't need to check for 6. Again, in the same case, for 5, we can start from 25, which we don't have here. But it's true, right? Because you can see from the observation that for 5, 10, 15, uh, and 20 are already crossed out. 10 is crossed out because of 2, 15 is crossed out because of 3, 20 is crossed out because of 2. So earlier numbers are already taking care of it. So on the based of observation, we can say that we can run the J loop from I square till n. So it's it will you need to think again and again to get the hang of it. What I'm saying. If you guys have understood, it's pretty good that you have built the logic that fast. Okay. So yeah. So in this way also we can do. Now moving on. Can anyone tell
Yeah,
me the
but it will
complexity?
cut out the numbers which are
Yeah, sorry.
squares. Like, it will the two will cut. Four will be cut. Then nine will be cut. What about the numbers which are in
Yeah,
between?
yeah. In between. Okay, one second. for which part you're saying from this 14 to 15th line for this one?
Yes, yes, sir. I can't
What
understand
your
the
doubt
concept.
was?
Can
Can
you
you repeat it?
like if we start from I square means 2 ka square is 4.
Okay,
Then 3 ka square is
concept
9.
was
Then
it's the
बीच
observation.
में
We are just starting. No, no, no. Okay, we are starting out from 4. 2 square is 4. Then it goes on simply. Then because the further condition is j plus equals I. Then we are moving step by step of I. That is to explain you again. Firstly we'll go from 2 to 4. Then 4 plus 2 is 6, right? Because it was j plus equals I. Then from 6 we'll go to 8. From 8 we'll go to 10. So it's same. So in 2's condition you will say that it's same as 2 to the 4, 2 to the 6, and it's the same. But for the 3's condition, instead of checking 3 to the 6, we are starting from 3 threes are the square of 3, which is 9.
okay.
I guess there is some network issue from Kshitiz's side. Guys, just wait for a minute. He will be joining soon.
Till then, if you have any doubt, you can ask us. Like we'll try to solve it.
Yeah, you can just put it in chat box.
Or anything you want to input, give input, like anything, suggestion or anything else.
Hi, Kshitij.
Sorry, I got disconnected. Okay,
Yeah, no
I'll just
problem.
I'll just wrap out. Just one last logic is left. So yeah, fine. I was explaining that observation-based logic here. So I hope that was clear. So it was like based on the observation that we can directly start searching from square terms instead of checking out from twice or such numbers. So that's the thing. So can any of one of you like tell me like only two things are left after this 5 minutes of work is left. So can any one of you tell me like what will be the complexity of this code which you discussed right now? Okay, I'll move with the complexity part. Just a second. Okay. So its complexity would be n log n. So I guess that you guys might not have studied complexity topic. So if you are not familiar with it, so ignore it for now. But I'll tell them for those who know the complexity topic. So in pretty terms, in simple terms, we first of all we'll checking for n with 2's multiples. So we are going to we'll checking for n by 2 terms, right? Because we are only checking out for 2, 4, 6, 8, 20, 8, 10, 12, and so on. We are leaving out all the other elements. Similarly for n by 3, for 3. Then similarly for n by 5, and it goes on. N by 5 and n by 7, n by 7 plus plus plus. Because we are only checking out for the prime numbers and divided by n. So if we take out n, it will be 1 by 2 plus 1 by 3. Yeah, I know that it will be going above your heads as of now if you have not studied the time complexity topic. So it would be n, and this sums out to be log log n. When you solve this mathematical expression, it's still 1 by n, right? So just to keep in mind, you can have like, yeah, big O of n log log n. I just told you the uh, in short like how we got out to that. Now, just the last topic, Wilson's algorithm. It's a pretty small topic. I'll cover it out in 5 minutes. So, why do we use Wilson's like what Wilson's algorithm is, or what Wilson theorem is? Suppose what Wilson's theorem states is: suppose you have a natural number, that any natural number which is greater than equal to 1, right, is a prime number if and only if that number is prime only if and only if p minus 1 ka factorial is equivalent to minus 1 mod p. This is one equation. Or the equation is same as uh, p minus 1's factorial is equivalent to p minus 1's mod p. So these are just, you can take it as like equations which we are given to you right now to check whether that number is prime or not. Say in the case of p equals 7, if p is 7, we need to check that whether p7 is a prime number or not. So p minus 1 factorial. What's p minus 1 factorial? P minus 1 is 6. 6 factorial is 620. Sorry, 720. And 720 mod p. I'll explain here. Yeah. So 720 mod p. What's p? P is 7. 720 mod p is 6. Okay. And so we got this one. So 6 equals, now we need to check minus 1 mod p. That is minus 1 mod, what is p? 7. And if you know how to solve this, what's minus 1 mod 7? It's 6. So we are getting 6 equals 6. That means it's true. This implies 7 is prime. Okay. So basically, it's not used for like checking whether it's prime or not, but keep this algorithm in mind. And now I'll be telling you where we can use it, where Wilson algorithm is used. Suppose there is a problem given to you where you need to compute the factorial modulo of the factorial number. You need to find the modulo of a factorial number, which is a prime, and that modulo number is given to you is prime. So it suits the condition here, right? So at that place you can use this Wilson's algorithm. Why now? Why we need to use Wilson's algorithm is, suppose for example you need to find 25 factorial mod 29. So you will say to me that I will find out the 25 factorial and then simply do mod. Why I need to use this algorithm? The reason is the 25 factorial is a huge number. If you calculate it also, right, in the scientific calculator or so, it's a very huge number, and it's out of this. It will come out of the time complexity in your programs. So that's why you can try it out. Okay, so 25 factorial is a huge number, and then you will do the mod of that. So it's a very complex method. Instead of that, you can use Wilson's algorithm. How and why Wilson's algorithm? Again, let me tell you quickly in 1 minute. Uh, if you guys have know the like in 11th or 12th, you might have studied that, for example, 25 factorial is same as 28 factorial minus 28 into 27 into 26, right? 25 factorial is same as 28 factorial minus this. And why we are having 28? Because 29 is a prime, and according to the Wilsons, we were checking p minus 1 ka factorial, right? So we are making it into Wilson's algorithm's theorem. So that's why 28 factorial minus this is same as 25 25 factorial. And now if you need to find out 25 factorial ka mod p, so we can do the same here in this whole situation, right? Mod p, it goes out here. And since we already know that 28 factorial mod p, what's that? We already got from the Wilson's theorem, it's minus 1 mod p, right? So we have solved out the huge part, 28 factorials mod. We have just solved out in a one line instead of computing the whole factorial. And for the rest part, as it's given here, it would be minus 1 inverse of 28 mod 20, that 29 inverse of 27 mod 29 from here, right? 26 inverse of 26 mod 29. So these are simple problems, and this whole huge chunk of problem, which was 28 mod factorial, we have solved out in a single line. So that's why we use Wilson's algorithm. Now we are pretty much covered for the today's topic. I'll just show you the practice questions which you can uh, do by yourself. They are pretty basic ones. If you understood the session of today, you'll be easily able to do them. So I'll share out the this presentation's link, and you can have a look at these four problems. First one is based on that G- GCD. Second one is based on prime sieve. Third one is also based on prime sieve, and the fourth one is based on Wilson's algorithm. These are pretty basic ones. First one is basic. Second one is basic. Third one you can use your mind a little bit, and fourth one is also kind of that. Now you can have a look by yourselves some common errors and mistakes. And these are some resources which I mentioned apart from the topic. If you want to learn any other topic, say in DSA or such, so these are all pretty tracks given by coachship. And one more thing, this CP algorithm site, I wanted to show you guys. Every other competitive programmer who is into these algorithms and all, it's a like uh, best resource for them. You can see here all the algorithms are given here in a summarized manner. And here, if you like what we studied today, right? C of arithmesis. You can go here and you can see the implementation, every explanation, code, and at last they have given you practice problems for the topic. So if you talk to uh, any of the like good CP person, he'll definitely recommend you. And I'm also recommending you. I like used like I've used this website quite a lot, and it's very helpful. So you can have a look at it. And at last, any questions for me that you want me to address? And I hope that the session would have been quite informative for you. I'll share out the link. No, right? Fine.
Binu, we will share the link in WhatsApp group and Discord server, so you don't need to worry. That's
Yeah.
great.
Also, I also gave the black box link in the chat box. You
Yeah,
can
that's great.
use that. Okay. I'll stop sharing my screen now.
Yeah, Kshitiz, I think it's restricted right now, the document you shared. So you have to give it public permission too.
Okay, I cannot stop sharing.
You can stop sharing right now, like the doc you shared is restricted to only you.
Oh, okay, yeah,
Yeah,
okay,
yeah,
okay, sorry. I'll change that.
yeah. No issue. You can change it later. Okay, so thank you, Kshitiz.
Yeah, thank you guys for like Coach of UMIT and CGC for inviting me for today's session. And I hope that you guys might have learned something new and enjoyed the session. Yeah, that's
Yes,
it.
it was really an informative session. Thank you for the session and thanks for your time and knowledge.
Thank you,
Yeah,
sir.
thank you guys. Thank you.
Also, one more thing, like we have pasted a feedback form in chat box, so everyone please fill that form so that we can improve ourselves and the speaker will know like how we do it. And also join. Paras, you
Also,
can
on this
PM.
Sunday, we have a peer programming session on this topic. So, yeah, we hope you join there at 6 p.m. and we'll be practicing, the questions and all from this topic.
Yeah, and please fill the feedback form in chat. So session is over from our side. Like if you don't have any doubt, you can leave.
Yeah.
No, Vasu, like sessions are on Tuesday, Friday, and Sunday. Like on Sunday, we have peer programming sessions and contests.
You can join our group, WhatsApp group or Discord channel where you'll get the timetable.
Yeah, we'll be sharing the social media links in chat box as well as on WhatsApp group.